Good afternoon, everyone. I'm from Avansaţi E3D, and I'm making a presentation about 3D printing. Just to start, how much do you know about 3D printing?
How much? We've heard about it, but
Yeah.
too much. Not too much.
Not too much. Okay, so if I'll be too technical, please stop me and I'll try to explain some things. Otherwise, there's a Q&A at the end. I will give about 15 minutes for Q&A because there's really lots of questions. So we will have time to answer them. Okay, let's start. So this is the outline. First, I will say something very broadly about 3D printing, what it is, how it works, what's the current what's the current status, basically, how big market it is, how big industry is it. Then I will go on to the future of 3D print, not immediate future like next year, but I'll be outlining the possible evolution of the whole industry. And some things might not happen, some things might. So we will see how that goes. Then I will say something about why so B3D, about our company, and about our product. And then it will be 15 minutes of Q&A. So 3D printing as such is also called additive manufacturing. It's a method of creation things based on the computer data. As a normal printer, you get your document in computer, your board, or your PDF, and a regular printer prints it on the paper as a text or as a picture. 3D print is a similar thing. It transforms data into real object. There are different technologies, I will speak about that later, but they have one thing in common, and that's that they're creating the model layer by layer. That's why it's also called additive manufacturing, because you add a layer on the top of the other. The biggest difference between tooling or machinery or CNC and 3D print is that you don't have any waste, or very little waste. If you have to make something with a CNC machine, you take a big block of material and you cut away pieces from it, and what remains is the final product. In 3D printing, that's not the case. You print the thing, and there is no waste, no offcuts. There might be some post-processing required, but generally speaking, the waste is much less of the cost than in CNC. The biggest benefit of the whole 3D print of all technologies, all uses, is that it cuts costs and saves you time. Basically, instead of getting something created by a traditional way, either when we are talking about, for example, molding, if you need to have the mold created by someone, usually created on wood, for example, and you have to have someone who will cut it away. It will take a long time, you will have to pay, and it will be very expensive. The 3D printing saves you time because it's generally speaking faster than, for example, CNC machining, and it's cheaper. And when we're speaking about cheaper, it's much cheaper. Something about the history, how 3D printing came to be. It's not very new. Maybe you just heard about it recently, but it's been around from 80s. The first 3D printer or stereolithography apparatus was created by Mr. Hall in 80s. He also created a company called 3D Systems, which is still on the market. It's one of the two big players. The most used technology in 3D printing, called fused deposition modeling, was invented in 1988 by Mr. Crum. And Mr. Crum started this company. It's called Stratasys. It's the other big player. So logically, you see, if you're first to something, it's good to stay in it because they're now basically the kings of the table. In 2005, a company called Repra created first home use or maybe hobbyist 3D printer. It was basically a kit bunch of pieces that you had to put together. You had to basically type your own controlling code on one of the small Android-based Raspberries piece or something. So it was really do-it-yourself project, a bit geeky for the technical people. Mainly just the garage projects. In 2008, a web page called Thingiverse was founded. Thingiverse is one of the most well-known web pages in 3D printing. It allows sharing and exchanging and uploading 3D models. Basically, if you're looking for a 3D model of something, instead of creating it yourself in AutoCAD or some similar program, you can download it, generally speaking, for free, which is quite awesome because you have a really huge library from things that you would have to buy, like pieces for bicycle, cup holders, or really just decorative items or statues or toys. In 2009, a company called MakerBot was established. It was the first desktop printer you didn't have to assemble yourself. Basically, as you took it out from the box, you just had to put in some pieces, but you don't have to build it yourself. It was already built for you. In 2010, our company, not yet B3D, it was still called Do It, and we were mainly IT, created our own 3D printer, by the time called D-Orange. It's already not on the market, and we have a new model which is much better. And in 2012, kind of a big change happened in the 3D printing, and that is that the MakerBot company, which is mostly desktop printers, was bought by the Stratasys, the big industrial player. That was first sign of, let's say, establishment in the market, that the companies started buying from each other, and it was the first investment or large investment in the desktop 3D printing. The price for the company was $403 million, so quite a nice sum. Now, I will say something about the technologies in 3D printing, so you have some idea what it is, how it works, and what it can do. The oldest technology, SLA, is also called stereolithographic. It works by hardening resin, basically a liquid, via light. Basically, you have here a tank with a liquid, and here you have, or down there's a reflector that shines through the liquid, and then it hardens up here. Then this part moves up a little bit, just one layer, and the same thing happens again, and that's how the layers are created. It's very slow. It takes tens of hours when you're speaking about the model, which is very slow. On the other hand, it's very precise, and it can create transparent models, which none of the other technologies can do. That's the reason why it usually is used for jewelry or glass making companies. Swarovski, they use SLA machines, and this is basically how the product looks like. The biggest problem is that you're very limited by size, so you can't create big objects. That's why you usually see objects only of this size.
Yes, but you can compose objects.
Yes, sure, you can. The other big or industrial technology is called SLS, which is selective laser sintering. It works by melting together pieces of metal powder, as we can see here on this picture. Basically, if you look here, these are the layers. This is the unsintered metal powder, and that's the laser beam that melts them together. Again, it's very precise. It works with metal, so we can create actually functional parts, which the SLA or the other technologies can do with some limitations. That's why it's mostly used in automotive and in production. And when we're talking about time, it takes really long times, days, to create even small volumes. And the machines are very expensive. Basically, they're 10 times more expensive than a similar value in a different technology. Now, that's the most used technology about which I will then speak about for the rest of the presentation, except for some exceptions. It's called fused deposition modeling. How it works is that you have a string of plastic, which is right here, that goes up to a melting head or printing head, which is right here. There it's heated up, and then it's deposited via a nozzle on the printing bed, which is here. As it's melting, it's limited to work with thermoplastics or some other materials which can be melted but will not burn. It's the simplest, easiest to build technology. That's why there is a huge amount of companies that do these printers, and also it's quite often used in basically not really printing, but to showcase something. That's why this technology is shared by printers that work with chocolate or cheese. The most important thing about this technology is not really the printers. They're basically quite comparable, but what you're interested is in the filaments. That's what you're printing with. That's when it starts to be interesting, because you got different filaments with different effects and different characteristics. You got hard ones like nylon, which you're able to use in really machine parts, gears, and so on. Then you got even flexible ones, which are soft, which you can bend, and then they retain the original shape. And of course, you got biodegradable materials like PLA, which is made from starch, or ABS, which is based on oil, but it's the Lego, is the plastic which Lego is made from. As I said, this is the easiest technology. That is the reason why it's mostly used, and it's the cheapest one both to buy the machine and also to run it. That's why it's the mostly used technology. Right. The current state of 3D printing industry is about the same as internet in the 90s. Why do I say that? It's because even in mid-90s, the internet existed. The technologies were already there: emails, web pages, whatever, sharing, TCP/IP. But no one really did use it because they had no usage. Some companies did, but there was no really no benefit for end user. Now, 25 years later, who of us doesn't have a internet in his mobile phone? We all do. So I believe the same thing will happen with 3D printing. Currently, we see a slow uptake in home use. Basically, we got people now buying it for home use and not for a job, and they use it both for fun, as a toy to play with, but also for their DIY projects, fixing things, modifying things, and creating things. The technologies that exist are still in development. We have not reached the final point where we will be just looking for new solutions and new usages. The filaments I spoke about in FDM, there's still, you got a new filament every week basically, with different characteristics. Conductive materials. You've got one which you can create an implant from, and it will decompose. You've got really huge portfolio of choices that you can make, and what you can do. Currently, the whole industry is fairly small. It's only about $4 billion worldwide. That's not too much, but it's expected to grow to 20 billion by 2025. I think that's actually a fairly conservative suggestion. I presume it will grow much bigger.
Where did we go? Gain spot.
Sorry?
It's behind.
It's next to be on the
Yeah,
presentation.
the presentation.
At the bottom.
Thank you very much. Yeah. So when we spoke about industrial use, these companies are already using 3D printing. All four. Volvo use them for truck product pieces development, and they got turnaround time by 95 or 94%, which is in time-wise a huge amount, especially when you think about how big Volvo is and all the processes connected to the production. Airbus had the 1,000 parts 3D printed to deadline, so you already see that not only it's for modeling or development or rapid prototyping, but you see them in use, you see them in your airplanes, and you see them in cars. NASA is using 3D printer, of course. There's one on the ISS, which has a really, you see the idea there, that instead of sending some new tool or new spare part by spaceship, because that would be hugely expensive, you basically create a 3D model, you send it by an email, and they print it themselves. That's that's what actually happened. They printed Ratchet Wrench. They designed it in Seattle, and they emailed it to ISS, and then they printed it. The same idea stands behind the Chinese Navy using the 3D printers on board of the warships. You've got a big machine which breaks all the time, so you need to have spare parts. Instead of having thousands of spare parts under your deck and wasting your space, you can have a 3D printer and print it anywhere you can. Similar idea now stands behind Amazon. They are trying to patent an idea that you order something, and instead of taking it from a warehouse, shipping it to you by post, they have a 3D printer and in a delivery truck, and on the way to you, they print it.
Print a laptop or?
Not yet. I'll speak about it a little bit later. And then you have the maker movement. That's the home use. That's your do-it-yourself type of guy. It's a completely new dimension of do-it-yourself. Before it was, you have a tool, you fix your chair. Now you just print the chair and basically design it on the computer. Everybody now uses it on the computer, and you're able to do that. And as we said, there is no technology that would exist that would not find a connection to sex. So logically, 3D printing is hugely used for sex toys. Unsurprisingly, you can find them as well online to download.
It's not like they delivered by Amazon.
The future of 3D printing. Now I'm speaking not about next 5 years, but 2025, 2050. Basically, there will be a 3D printer in every home. You ask why? Because you don't need it. But imagine your spare parts. Now you have to go somewhere and buy them. Then you will just log onto the webpage of the manufacturer. You will find spare parts files. You download it. Maybe you pay something like 10 euro cents, and you print it on your home printer, and you put it into the machine yourself. That has another thing.
If it's not made of iron, or something more strong.
It will be no problem. Basically, you will have an FDM technology which will be able to print metal. It's it's a bit more complicated, but it already exists. Now we just needed to incorporate it into the machines, and that will be done. Because every company will have a 3D printer, it will end the Chinese domination of manufacturing. Why? Why? Because nowadays everyone is making it in China because it's cheaper. But when you don't have to pay the person because a machine does it, you don't care where do you produce it because the electricity costs everywhere the same. And because you don't produce it in China and then ship it somewhere else, you save the money you will spend on shipping. It will completely change shipping. There will be no more thousands of pieces being shipped around the world because you will be able to create everything basically in your home or in your office or in your company. It will also simplify production and development so much that even a small company will be able to fastly get into the business and start creating and building their things.
You also save the whales, practically. You also save the whales.
The whales, yeah. And
Stores will be smaller.
Exactly.
You go and buy powder.
Yeah. And what you will see are complex functional items. Now, generally speaking, with most of the FDM printers, you print one material at a time. So that's not really the way it will happen. What will take place is that, as we know, or as I said, you can print now conductive material. It leaves electricity, so you basically, if you have a printer which prints with two materials at once, you can create a computer chip. And if you can create a computer chip, then you can basically create a machine that will run on electricity and that will move. And if you're able to build a machine that moves and runs on the electricity, then you can create basically anything. So not only you will see machines being printed, but you will see items of clothing, furniture, basically anything you can think of, it will be able to print it with the same or better characteristics than you see nowadays. Right. Now I will switch to something about our company. We are Wysoft B3D. We are part of the global Wysoft corporation, which is based in Czech Republic, in Brno, but it's worldwide. We have offices in Singapore, we have offices in Japan, we have offices in Australia, in the Middle East, in US. So we are really from Czech Republic all the way to the world. We have an in-house production and development. Why do I say in-house? Because the printer I will speak about in a minute is not made in China. It's made in Kralupy-nad-Vltavou in Czech Republic. So it's a good piece of European machinery. And as I said, you already see a transition from the Chinese manufacturing back to home.
Is it 3D printed?
No, there are
Not yet.
in the printer there are no parts that will be 3D printed because it would still, ball screw. You need it to be made from metal, and it's still cheaper to have it created traditionally. Sorry?
You have the metal created in China.
No. The ball screw is Czech as well. Half of our company, half of the company is R&D, because in 3D printing, if you don't develop fast enough, you will stay behind the competition, because the competition is very fierce and development goes very fast. We develop and produce FDM 3D printers, a desktop one, D-Green, and large industrial one, D-Red. We also have our own software for preparing the prints, not for creation, that's your AutoCAD, Rhino, SolidMaker, but it's a software to process the model before printing. Now we jump to the smaller printer, the green. It's green because there is a green on it. So. And also as well because it prints mainly with PLA, which is one of the filaments made from cornstarch, which means it's ecological. So again, it's the responsible thing to do. It's really small office, home office printer. It's fairly smallish. The print volume is 15 by 15 by 15 centimeters. But as I said, that most printers can be compared together. The print resolution or the speed are quite comparable. What you want to have is the edit value, which in this printer is the user friendliness. It really takes 2 clicks to start printing. Our blonde office manager uses it, and it's really simple to use. The first day I've been at the company, I was able to start printing, and I knew nothing about the printing. It's got some unique safety features that make it great for both education and home use, because if you open the door, it stops printing, so your kids or the students don't get hurt. It's currently printing with only one material at a time, but the portfolio of materials that it can print is growing basically every month. We order new filaments, we find out how to print them, and we add it to the portfolio. Here are some few kind words that some people said about Nifreen. CNET.com is the American consumer market review-based web. It's the biggest web page in there. They tested our degree and they were very satisfied with it. 3D print is logically about 3D printing, and 3Dvisor is a young Czech company that has a biggest portfolio of 3D printers in Czech Republic and the biggest showroom. And we were working with them, and they were really glad that they're able to sell this product. That's too much. Right. So this is D-Red, the industrial one. It's really large. The build volume is 60 by 40 by 80 centimeters. That makes it one of the biggest machines in the field. It's a, why I say industrial? Because it's not only big, but it's a modular solution. Basically, when we develop a new model for printing with new material, like carbon or Kevlar, then you can buy, the customer can buy the add-on and put it into the printer, and they have a bigger, basically the machine doesn't lose its value, it gains value. It's a great value to cost ratio. Basically the nearest comparable machine costs more than 3.5 times more, which is really great. It's able to print with 2 material on one print. We are currently pending, we have a pending patent in that, and that's really important for the industrial use. Here you see a print we did for automotive business. They were developers of turbo systems. The gray bar is the model as such, and the white bar is supports that you need during the printing. So basically, this bar doesn't collapse very quickly, so that's why the support is here. But this support can be washed away by water, and then you have a exact copy, only it's in plastic, it's not in the metal. You have empty tubes, this space here is empty as well, and that was really important for the customer. Right, so that would be our product portfolio. Thank you very much for your attention. And now it's Q&A.
I have a question related to the D-Red printer.
Yes.
So, by being able to print with 2 materials at once,
Yeah.
you can practically print the support pieces in different materials, so you can clean it up afterwards. You don't
Yes.
have to create the support in the same material, right?
Yes, exactly.
Traditional print.
Yes.
You said that it's really time consuming and yet AFS saved a lot of time. How is this possible?
Well, basically because it's faster than the traditional method.
Really?
Yeah. Because if you have a what they did, they used FEM machines. If you would have to have it inject molded,
Okay.
basically to create one piece, you would have to create the molds and put the whole industrial stuff into movement. Here you just upload it to a printer and you start printing. And you don't have any waste, you don't have to create any molds and all that. So that's why it's faster.
I have some questions
Yeah.
about the deep green software.
Yeah.
I saw your presentation with your colleague yesterday. What kind of files can you upload to the software that you can print?
It's standard files. It's STL, OBJ, and 3DS.
So you can import OBJ and 3DS as well?
Yes,
Okay.
that's basically the files that you export from your CAD software, solid makers, Rhinos, all these 3D modeling software. You can upload into the so-called slicer because it slices the model in layers, and then you create a movement map or movement orders for the printer.
And if you import a OBJ that's practically more than one object, because you can export an OBJ with separate objects.
Yeah.
Does the software separate them and spread them on the workspace?
It doesn't separate them because it's one file. So you put it in there, but it can print two. It doesn't. It can be 3 or 4 objects on the printing bed at one time. But
when exporting the OBJ, it's best that you spread them out yourself, right?
yeah, sure. You will not be able to move the objects after that
Yeah.
because the software doesn't recognize them as separate objects.
Only if they're imported separately.
Yes, exactly. In that case, you can move them around and so on.
And can you set in the software? Can you set the resolution?
Yes, sure. Basically, the software is the part of if you have a word and you type it, that's the AutoCAD part, and then you choose the settings for printing, color, 2 pages per sheet, and so on. So that's what the slicer does. It allows you to choose settings to make the model larger, smaller, turn it around, position it in the printing space, and then you choose the resolution, the speeds, which material you're printing with, which is quite important because each material has a different melting point, for example. It allows you to choose the support system and how much material will be put inside the model and all that. So that there is quite a big list of settings which you can change on the model.
Okay, because I saw that D-Green is practically one box and that's it.
Yes,
That's the printer.
yes.
For example, with the multimaker,
Yeah.
it's just the structure and you can see every moving part, so that's easy for maintenance. How can you do your own maintenance for the D-Green, for example?
It needs no maintenance, basically. That's the thing.
What if your nozzle gets stuck with material?
Then you just unscrew it by hand and you screw in a new one.
Okay.
That's why we have so big R&D. We are trying to get the stress away from the end user and think instead of him. That's why D-Green needs just 2 clicks to start printing. Because
More user friendly.
exactly, yeah. The more easier to use it is, the more people will use it. That's our kind of concept. That's also why it's closed, because you don't want to get stuck in the machinery, and you don't need to do the maintenance. That's why D-Green is completely closed, and that's make it easy, ideal for home use. So that's our kind of idea.
Do you have any customers in Romania?
Not yet, but or not that I know of. But I presume after this event there will be some printers.
And the price for this?
It's, oh, guess the price.
I already know the price, okay? It's not fair.
10,000 euro for the small one.
How much?
10,000 euro for the small one.
No, it's 1,815 euros, including TVA. So it's very user-friendly. If it would be 10,000 euros, no one would be able to buy it. But the price is very competitive. The large one starts at 15,000, so that's quite understandable because it's big.
What's the weirdest object that you've been asked to create?
I'm sorry?
What's the weirdest object that you've been asked to create?
I asked him last night.
In the beginning,
You can say.
Yeah, I can. In the beginning, we tried to get some publicity, to get some PR. So we invited editors and guys from Maxim, which is like a lead mag, basically, magazine, and we scanned and printed their penises. So that was one of the weirdest things we did.
The scanning or the printing?
I would say scanning was weirder.
So, who had the longest, who had the longest printer?
Well, the largest item of penis shape we did was on the large printer, so it really was.
Yeah, so it was larger than 15 centimeters, right?
Oh, well, it was about this big. It was a gift for our marketing guy for his.
For his good idea.
Yeah, for his facial party, and he had to carry it around during the whole party.
And what material did you use? Do you use the rubber-like material?
No, we used a black one.
Metal.
You should have used the brass-like material so he can make it more shiny.
You asked about parts for metal.
Yes.
Basically, with the FDM, the limitation, there is a limitation in plastics. But already someone got a great idea that basically you did a plastic and mix it with the metal powder, and then you print with it, and then you put it into a forge. You heat it up, the plastic melts away, and you get your finished metal product.
But wouldn't that make it more air filled?
No, not really, because it would.
Would it shrink?
Sorry?
Shrink.
No, not really, because it will forge the metal particles together. So they will close the holes themselves. But it's.
Have you seen brass-like material being really shiny? Really shiny? Because I've seen
Yeah.
3D model, it was like, I think it was iron or something like that. And after printing it, he put it into heater,
Yeah.
something like this, so nothing that melt away, the plastic will melt away. And then he put it into an industrial shiner
Yeah.
with rocks and stuff like
Yeah.
that. And it actually looked like real brass.
Yeah, you can polish it and it's very shiny, but with the bronze and brass plastics have a big problem because they oxidize a lot. So we have models made from the bronze plastic, and it actually gets blue after some time because as people have limited around on the exhibition, the sweat from their palms, it oxidizes it, so it really is like bronze. Right. Any last questions? Okay. Thank you very much for your attention. And if you have any more questions,